Good morning, everyone. Very, very, very warm welcome to all of you on a cold morning here in Düsseldorf. Welcome to the C3 AI Reliability Summit. You're in for a feast of insights, and I'm very glad and very pleased that my colleagues have been able to join us. Following me, we'll have Adi, who's come over from San Francisco, the same with Lila, and we are very grateful to have our colleague Richard from Shell as well to speak to you and share lessons learned on reliability and predictive maintenance across their asset portfolio. Okay, so in terms of the agenda, you've got me for a few minutes, and following me will be my colleague Adi, who will talk to you about AI applications at scale. That'll be followed by Lila, who will talk about and get into more detail, really the richness of driving asset effectiveness with AI. We'll then break for 15 minutes for a coffee, some more coffee, never get enough coffee. And in that break, my colleague Sid, there will be a demo station outside. So if there's any questions about the technology, how it works, the data, anything like that, architectures, please do speak to Sid outside. He'd love to hear from you. After the coffee break, we will be back in here for a great session with Richard, sharing Shell's story and the journey they've been on with reliability and predictive maintenance. It really is a great story, and I'm really excited about it. After that session, we will then have a fireside chat between Richard, Lila, Adi, and myself. I've got some interesting questions, which I hope won't come as too much of a surprise to you. And then we'll break for lunch. So to warm things up, please raise a hand if you are from the chemicals industry. Okay, brilliant. And oil and gas? Okay. Power and utilities? And other process industries? Okay. Thank you. No, that's good. Last question. So who feels high pressure in making day-to-day asset decisions? Interesting. Interesting. You must have some brilliant technology helping you. Okay. So just to frame this event, before our speakers come up the front, I'd like to ask one question and ask you to keep that in mind as we go through the morning. And that question is, why is generative AI such a big deal for asset reliability and asset effectiveness? Hold that question in your minds, and hopefully we'll look to address it, or at least part of the question, in each of the sessions, so that by the end of the day, the end of the morning, you have a very clear idea about the answer and how to actually make it reality. So asset effectiveness is about achieving a desired result or outcome. It might be availability, it might be reliability, utilization, safety, or just straight profitability. People, no matter where we are, yes, we are striving for industrial autonomy in a lot of our assets and keeping people out of high-risk situations, but people do remain critical to the operation and decisions of our assets. So the human-machine interface is absolutely critical, and generative AI is disrupting that interface in a really big way. It's transforming the relationship between people, processes, technology, and the physical equipment that is driving value in each of our businesses. So it's a lot more than just a dashboard or a search interface. It really is a game changer for superior decision making. So with that, that's enough from me. I'd like to hand over to my colleague Adi to speak to you on AI applications at scale. Each of our speakers will introduce themselves briefly, and for each of our sessions, we'll plan to deliver the content and then keep enough time for some questions and Q&A after each session. So with that, would like to welcome Adi. Thank you very much.
Good morning. Thank you all for making it. I hear there were a few fun disruptions with traffic and trains and planes and everything else along the way. So really appreciate you all making it. Like Duncan said, my name is Adi Bhashyam. I lead all of our customer solutioning teams at C3 AI. I've been with the company now, I think 8.5 years, going on about 80. It feels like that at least. And prior to that, I was with McKinsey for 12 plus years in various sectors, and I'm a computer scientist by training. I've had the fortune of living this journey not just at one place, but at 50, 70 different customers of ours as we run them through this process of starting with one use case, trying to figure out what to do, get value from it, and then help to scale. And it's a very inspiring journey because you see companies change, you see people change as you get into that process with the aid of technology. The key, though, is ultimately this becomes a people sport, right? You're assisting or enabling processes with the aid of technology and not replacing them. So really thinking through that process and really thinking through how that plays out is key. Let me give you a little flavor, hopefully this works, on what we do. At C3 AI, our entire focus is on achieving or helping with business processes. So what does that mean? Well, it means really applying AI, machine learning, optimization algorithms on massive amounts of data to solve business problems. And those business problems look like this. If you're in the process production world, this looks like predictive maintenance. It looks like yield optimization. So how do you manage a stochastic process with the right inputs to maximize yield in a variable world? It means energy optimization. So how do I benchmark and then draw down the amount of inefficient use of energy so that you can drive down a cost effectiveness or otherwise. In the supply chain world, this looks like inventory optimization, constantly and dynamically running machine learning and optimization algorithms to decide how much of anything to carry at what locations on any given day to reduce working capital and maximize availability of spares, availability of raw materials, what have you. We're seeing a lot of work in supply chain, in sustainability, et cetera. And all of our deployments have tended to be large strategic plays at our customers. So you'll hear from Richard shortly about Shell. I won't spend too much time on it. At Cargill in the food industry, we're busy doing a lot of supply chain and process-related work. So imagine all of their food processing plants in North America where there is variability of raw materials, right? How much you get, how much you're able to receive from your upstream suppliers. There are constraints on how long you can keep food processed on any given day, any given line. There are huge amount of constraints on what types of resources can act on what types of food, right? Just based on skills, specialization, et cetera. And our systems help schedule exactly what to produce every given day, taking into account variable demand functions from Cargill's customers. So you're optimizing the amount you produce to minimize wastage, maximize the capacity of the plants every given day, right? And this is now running in about 15 plants in North America, going to 30 by the end of the coming year. Shell is a multifaceted story. I won't get into it too early, but we'll take questions at the end after Richard speaks. At Koch Industries, we're active in multiple parts of the business, both in terms of predictive maintenance and equipment reliability for very large pulp and paper machines. So these things are the size of a football field or maybe 3 football fields. They're fully connected, soup to nuts. They're almost they're the pulp and paper equivalent of a refinery, right? It's just one big machine that starts from one end and comes out the other end. And we're helping Koch, Georgia Pacific, which is the Koch company that makes paper, on keeping the entire system working, doing root cause fishbone analysis dynamically as you detect a fault. Where is there an upstream event that could have caused it? We're now expanding into demand forecasting and supply chain optimization between plants. So how much should one plant make to meet the demand supply function of a second plant in order to go from there? We're doing supply chain optimization for market demand. So a lot of you in the chemicals industries need to decide, and petrochemicals need to decide how much to make, where to place it, what market spot rate to pick for what in order to trade, and so on. And we're working with one of the other companies in the Koch family called Flint Hills in order to do market-based inventory optimization. So where do I place or where do I draw down from based on the market demand for the next X days on a continuous basis? And at Bank of America, we're doing a lot of work on what we call transaction monitoring. Imagine all of you as companies having business relationships with a bank. We're watching, where our systems watch the entire transaction flow, product flow, relationship flow between one of your companies and the bank in order to assess for things like revenue opportunities, churn prediction, things like that, as well as monitoring transactions in near real time, right, that attach the market. Now, the reason we're able to do all of this at the scale, and I think I want to underscore the scale of this. This is not science experiments. This is not one-off, let's prove this works. These are production systems working in mainstream processes, running as part of day-to-day operations, right? And to get to that point, it's an order of magnitude, maybe 2 orders of magnitude more complex in order to get through all of the pieces that you need to solve for. And the way we're able to do this is a combination of the technology that we have assembled over the last 13 years as a company, and also working very closely and collaboratively with our customers. Let me talk a little bit about the technology for a second. If you take any of these examples, I'm sure it's not lost on you. A large problem here is how do I make these optimal decisions? And the way you do that is through the right amount of data and the right algorithm. Well, easy to say, hard to do, right? Because the right amount of data is all your systems in multiple places, sitting all over the place, different formats, different IT governance rules. How do you pull all of that together? How do you keep it continuously updated as these things change? Some of these data sources change at the rate of every second or 10 hertz or 50 hertz. Some of these data sources change once a quarter or once a year, right? Some of these are done once. Your PNIDs for your plants are done once and they're stored somewhere in a PDF file with no ability to use them unless you can pull them in. How do you use all of that information seamlessly? Huge problem. If you can solve it, that's the start of a very strong foundation to then go from there, right? The other piece of this is how do you dynamically serve up and continuously process this information to solve, let's say, monitoring 2,000 valves in a refinery, where every valve needs its own machine learning model. That's 2,000 machine learning models that you have to manage seamlessly and dynamically all the time, right? And the third piece of this is how do you then show all of that? Great, you can do 2,000 models or more. How do you show all of that information to someone who can use it to make a decision? Right? Should I intervene? Should I send a work crew? Should I change the production schedule? Should I order more parts? Should I call this supplier and say, why is your purchase order going to be late? I know it's going to be late. Tell me what you're doing about it. All of those are process decisions that you have to make on the fly as you run your operations. And in order to do that, we've spent a lot of time working through the technology stack that at the same time solves for this data problem plus analytics plus machine learning plus application capability while respecting every one of your enterprise IT security requirements. Right? Because we understand it's not straightforward or trivial to deploy software in an enterprise setting. There are considerations on where you do it, how you do it, what to use, what security, what lockdowns. And we've engineered the system so that we're compliant and we make that very easy to do. This is a lot of capabilities, but as operators and as you represent the business, what I'll tell you about the core platform, which is the first layer of our capability, is that what we have solved is the ability to deploy in your environment, connect to multiple sources of data at the same time. These could be historians, they could be SAP-type systems, ERP, they could be stores of files like your P&ID files or instrumentation files or what have you. Maintenance records or CMMS systems, all of the above, in order to create a continuously updated view of the data and then run analytics on top of it. Right? So for instance, we're able to say, what was the delta temperature in the outlet valve at the time, within 15 minutes, of a product transition? Right? That's a fairly complicated business or SME-specific capability. We make that easy to do within like one line of code or one expression in C3. And once you're able to do that at that speed and pace, you can then scale that up very quickly. For the two other pieces of information that I think are relevant at this level, right? One, we built this so that the system works on any cloud or on-premise environment. So if you have one of these clouds, we can deploy in that. If you have multiple of them, we can deploy in multiple of them, et cetera. And then second, we've made sure that the platform, which is this blue box, has the ability to expose the data consumed in it to business analysts, to developers, to your data scientists, so that you can use all the work that's been done for any additional use cases as well. So you get a huge amount of reusability and scalability as we get into this. The platform itself is designed to scale, which means you're not constrained once we build to only one location or only a certain amount of compute. It's designed to be elastically scalable. Right? So elastic scalability, we're flexible on the infrastructure. We're designed to pull in data from multiple places and process them continuously with the goal of serving these up from an analytics and machine learning perspective. What we've done on top of this is build applications. Right? And these applications are now full workflow applications, and Laila will show you a couple of them when we get into the reliability suite next. These are full workflow applications that are designed to expose to business users the right amount of insight on anything they're doing. So in the world that we call the reliability suite, that world looks like asset operations and process operations. So in Reliability Suite, we expose this idea of how do you monitor a fleet of assets, different types, different OEMs, different operating settings, while providing a common interface to monitor things, understand why they might fail or exhibit anomalous behavior, what possible root causes are, and what to do about it. right? All connected into one flow. And I think Sid will show it to you afterwards outside, and Laila might have a video or two. On the flip side, we're also, as you build this asset hierarchy and pull together how you monitor individual assets, we can also watch these assets as a process. So now you can connect up these assets and say, okay, for this process, what are the input and output parameters that matter? And can I learn through an optimization capability if there are set points that can change something, right? Energy consumption, yield, raw material consumption, etc. We just went live on a system completely different from yours and strangely similar, sugar production in Guatemala with this capability, where if you think about what they do, they have crushers for sugarcane that extract juice, that then process that juice at different evaporating temperatures based on the sugar content that's dynamically changing in order to get high concentration sugarcane liquid or juice that then they evaporate at certain temperatures to maximize sugar. Every one of those is a chemical process with 4 or 5 set points each, right? How much water do I put in, at what rate, with what evaporating temperature, with what pressure, in order to drive the process through. And with this, in about 3 months, we were able to prove that A, we can model the system end to end, and 2, we were able to squeeze out about 2 to 2.5% more yield for the same amount of sugarcane going in. Right? Completely different than your world, but at the same time, very strangely similar. Right? Because it's the same type of analytics that you have to do continuously. In the supply chain world, we do a lot of work on watching the end-to-end supply chain, starting with demand forecasting. Right? This is both raw material demand. If I need to make something, how much should I order? As well as finished goods demand. What is the demand function coming from my customers in order that I can better solve for that in terms of production scheduling or manufacturing plans or what have you. What we routinely see when we get into these things is the combination of more data. So we don't just use the ERP data in SAP, but it's much more data than that because we combine it with outage schedules, manufacturing schedules, in some cases promotional activity in a B2C type of environment, et cetera. In a B2B environment, we can pull in data from your sales systems and CRM systems. What deals will I sign in the next 30, 40 days that drive a demand function, and so on, in order to get far more accurate on the demand function, right? And so we routinely will see a reduction in forecast error by 50 to 60%. When we deploy these systems. We do a lot of work on sourcing optimization. So imagine you buy a lot of things. These look like commodities. These look like chemical APIs, et cetera, pharma APIs. What's the best way to monitor what I'm paying for them vis-a-vis market across all my plants? We do this for Baker Hughes at massive scale. Right? And so all of their manufacturing facilities globally buy similar things, but on independent contracts. We benchmark across all of them continuously and tie that to a best matched industry index. This could be a chemical index. It could be a raw material like iron and steel index, what have you, to see how you're trending vis-a-vis the market and continuously expose that to supply chain analysts. We do a lot of production schedule optimization, very relevant in petrochemical type operations where you're deciding what to make in what sequence and so on. We recently did this for a steel manufacturer in the US where based on the transitions from one grade of steel to the next, the amount of wastage you incur between those transitions or during those transitions can be optimized. So we were able to squeeze out, again, about 2 to 3% reduction in 2 to 3% reduction in the total wastage, but a few hundred, almost 1,000 tons in one plant, right? Of steel that is not scrap steel anymore, but is actually commercially viable. right? Just by figuring out what the right transitions are across all of these, across all of the constraints they have. We monitor supply networks globally. This is to predict what POs will be late, what shipments to customers will be late. And we do continuous inventory optimization to minimize working capital. Right, so given the demand function, given variability, when I tell the supplier that they've got to send me something, they're always late by 3 days and they're always 80% of what I order, the system can take that into account and optimize automatically. Right, you don't have to do it on a day-to-day basis. What I'm telling you are all business outcomes, not fancy machine learning talk, because that's what we do, right? We translate what the technology is to actually solve for what is the true business outcome that we drive for. And then finally, we're spending a lot of time now on energy management, and it's a loose term, but it's basically all resource management for processes. So how do you benchmark energy, water, other resources across processes? Look for opportunities to benchmark and optimize them. And at the corporate level, how do you streamline and optimize reporting? Right? And this is part of the ESG function or the sustainability function that we think will gain more and more prominence as we go along. Right? And you see all these things come together. For instance, you might have corporate initiatives to lower the greenhouse gas footprint of the manufacturing facilities as one of the big corporate initiatives we're running. And then the other applications that you see actually do that, like the energy management one. And those are coupled in a way that we can draw from one and use in the next. And the important part here, and I'll stress this again, is there's a huge difference between doing one-off projects on the side just to show that you can do this, to actually deploying these systems at the scale of the entire enterprise, right? All of your manufacturing facilities, all of your production facilities, et cetera. And the next few pictures just give you an illustration of that. At Shell, for instance, we went from doing one location to repeating it across almost 30 locations in very rapid succession. Right? Because what we build out the first time around is really around the core schema, ontology, asset hierarchy, connections between data. And then we can use that to replicate very, very quickly. And as we do this, this is hundreds and thousands of machine learning models, hundreds and thousands of sensors, hundreds and thousands of distinct rows of data being processed, millions of rows of data being processed every day. We've seen this at other places as well, and this really gives us confidence and conviction that we're doing this the right way. Right? Because remember, for this one thing to finish, it means that you've deployed the system, but also that people are using it, right, in a consistent way. We've done this at the Air Force, and you might think the Air Force is very well run in the US. It's also a lot of different personalities and people and everything else. And so getting 20 different platform is think of a platform as one type of aircraft, right? And that one type of aircraft might be in 10 different air bases across the US or globally. And now think of the complexity of deploying the system across 20 types of aircraft across all the bases in the US, right? That's what and now imagine doing that in a year and a half. Right? That's the speed at which we can run. The last bit of our software offering is all things generative AI. And for all of you following this whole thing, it's been a year now, I believe, since Sam Altman launched this thing with OpenAI, got fired, got rehired, everything else along the way. For us, I mean, there's different ways you can look at generative AI. The most simple way is to say, oh, this is a new search interface, and I can throw it up like Google Bard or any one of these tools, ChatGPT, in order to ask questions and do my homework for me, et cetera. Right? And that's fine. Where we see this really play out is in creating a knowledge assistant in these complex business processes that we just went through before. Right? So it's not enough to say, and so really in that sense, it becomes a new form or a new interface between users and very complex systems underneath. So for instance, one of our production systems that we deployed, the manufacturing facilities were seeing a lot of employee retirements. So the most senior employees that actually knew every single knob and every single blinking light were retiring. The new people that were joining were new, and they didn't know enough about really how the system worked. Right? These SOPs were like 500-page binders. It's like, here, read this. I'm like, okay. The telemetry for different systems was like 6,000 different sensors doing various things, and it's tough to take account of everything. The experienced operators were available, but you got to ask the right questions and so on. So what we've done here is really take all of these systems and create a unified view using a generative AI interface. I'll show you a short video after this that essentially pulls all of this together into a single chat-based interface that you can ask questions of for that domain. What types of questions do people ask? Well, it turns out it's actually gets from simple to complex, right? So if I look at the first one, that's what most of these systems do today, document retrieval, right? It's like, give me your documents, I will index everything and keep it all handy, and then you can ask me a question about what is the SOP to change the glass on this particular piece of equipment. Here is the SOP, right? What is the SOP to do something else? Here it is, and so on and so forth. That tends to be a lot of what should I do, very, very basic questions, or why is this occurring? Because you can read failure reports and say, okay, the most common causes for this happening are A, B, C. We call that category 1, right? It's typically text-only based, it's document-based, and it's fairly straightforward. I mean, it's still pretty complex when you think about it, but fairly straightforward from the state of the art of the technology. What we are also doing now is really everything in blue, right? And the word centerline is a pulp and paper example, but really the idea here is, can I also ask the same system what my how my equipment is doing, right? What was the variation in the spool rate versus the min and max that I have set for it? Now that's a far more complex problem because you're asking the system for data and how that data compares to some other data. It's not in a document. It's actually in a OSI Pi historian or a Aviva historian somewhere that needs to be pulled out and processed, along with the set points that are stored in the ERP system, along with an SOP that says don't let the allowable range for these set points is 95% to 105% of the value stored in the ERP. And you're suddenly expecting that the system is able to pull all of that together and then answer the question of, is my system okay? Right? Very, very different than reading text and throwing it back at you. Now, because we've invested in the platform capability that you saw earlier, we're able to answer that pretty quickly. Right? Because we're indexing all of these things anyway, and we're able to pull it all together in a way that makes sense. And so, am I within expected bounds? Right? The last time I made this grade of material, what was the max temperature at this sensor? Well, that means I need to go look at my production schedule going back in time to find the first instance of when I made this grade of material today, which I need to know from context. Go pick out the data for that time range, and then say, oh, this is what it was. There's a lot of reasoning that's happening, but it's contextual reasoning as it relates to data. We're able to do that. The last bit which we are working on right now, and the goal is we're on track to go live before the end of the calendar year, is open troubleshooting. So in this case, if you have maintenance flowcharts that say, hey, if you have a problem, first check this, then check that. And if those two things are false, then it must be this issue, go do this. Right? And you have various flowcharts that play out. We're actually programming those flowcharts into the generative AI system. So the system then says, oh, this flowchart is the following. I'm going to actually go check that, then check that, and then check that, and then tell the user, do this because I checked those two things and they're false. Right? Again, very powerful reasoning, but much higher level of reasoning than go look at the document and come back. Right? And that's the state of the art as it relates to what we're doing. The other piece that's important from a generative AI capability, which matters from a safety, security, IP protection, et cetera, is we've done a lot of work to separate and clarify how the system is architected so that we keep company data proprietary, safe, without exposure to other systems, other users, things like that. Right? So a traditional LLM, if you go to Bard or ChatGPT and throw a document in there and say, okay, read this and summarize it for me, what that does is index that entire document into the global corpus of all information, which means it gets blended in with everything else. It's exposed, so anyone else can log in and access it if they get into it. It also, these systems tend to hallucinate, give you random responses. They're forced to answer, right? And so they tend to hallucinate a lot, and you can play with it a little bit. There's also no enterprise access controls. There's information leakage that can happen across the board. What we've done at C3 is we've separated the reasoning engine, the brain, which is the chat interface, from the memory or the data store in a very explicit way. And so when you ask a question of the system, it then asks a question of the data store and only responds if the data store has the relevant information. So we separate the two. And that also allows us to place access controls on that back and forth. And so we're able to control who has access to information and whether they are allowed to access that information or not. We've also expanded it in green up there to all kinds of data. Right, so this looks like tables, this looks like documents, this looks like images, it looks like sensor data, all of these elements. And so what happens then is you get far more deterministic responses. You can control what information is used to answer what kind of question. You get full traceability across why the system came back with a specific answer, which then allows a human to either keep it or disregard it as needed. We can apply enterprise access controls completely, so there's no unauthorized use of information across the board. It also allows us to eliminate hallucination completely. So the system is allowed to and encouraged to say, I don't know. I can't answer that question. I don't know. Right? But here are some relevant pieces of information that you can look at. And we try not to force hallucination in. I mean, we eliminate it almost entirely. Let me show you a quick video that will illustrate a few ideas of that progression from document-based retrieval to telemetry and geospatial querying all at once. If it works, let's see. One more? Yes. So this is a wind turbine demo example, right? How might a wind turbine fail? This looks like documents. It says, okay, a wind turbine can fail due to electrical issues, grid failure, flash fail, or malfunction. Here are all the documents that I've found that allow me to give you that answer. You can look at summaries as you hover over these. And if you want to actually go look at the documents, click through and it pulls up. Right? There's search results and so on and so forth. Now, let's say you wanted to chat and you start something, you wanted to get a little more detailed in this context or in this domain. You say, okay, how do I fix an electrical issue? The system starts processing it. I'll go this side. Ensure there's no breakage. So again, this is document summarization, but it's looking at safety procedures as well as other solutions to say, okay, ensure there's no breakage, then go look at it. And you can provide feedback as you go. Okay, all of this is level 1, document reasoning. Okay, now I might say, what are the GPS coordinates for each wind turbine? Now, this is a very different type of query, right? Because now I have to go to my ERP system and say, okay, here's lat long of everything. And then the system decides, because this is geospatial, I'm actually going to show it to the user, not as a grid, but as a map. Right? And that's baked in as well. And then you say, what was the average daily generator rotation speed for each turbine in January 2022? So this is time and space and telemetry. It'll scroll up a little bit. And here we go. It's actually created a time series of a very specific KPI, generator RPM, for a period of time as you asked. Right? This is not asking an SQL query, but a very natural language type interface. And I think there's one more eventually that maybe this is it. And so you go from, and this is the start of these things, because now you can get into saying, okay, which of these was out of bounds? Or tell me the last time RPM was out of bounds. And you know that you can start reasoning through that as well. I think that was it. So just to summarize, I think what we've been in the business of at C3 AI is really building these enterprise AI solutions, right? They combine machine learning with optimization capabilities plugged into real-world business processes. In order to do that, we've built on the back end a very powerful data integration unification capability, as well as a continuous analytic processing capability, as well as visualization. And we then surface that up either through pre-built apps, so reliability suite, supply chain suite, sustainability suite, or in this generative AI interface, or both. And as Lala will show you, we're starting to put those two together now. That's really our business. That's what we do, right? And we obsess as a company about delivering value to our customers. So it's a non-stop conversation about why is this valuable? Are we solving the right problem? How can we tweak it so that it gets sticky and gets used? And that's the nature, and that's what we do. And that's what we do, and that's what we're looking to engage with all of you about. Okay? I'll pause there. If there's any questions I can answer now, happy to do so. Otherwise, I'm around. Please.
Yeah. Good morning. My name is Louis Pruitt, and I work for AI and Generation.
Hi, Louis.
Thanks for the presentation. It was very interesting. When you introduce a platform like C3 with a customer, what do you need to put in place to manage the data with that customer?
Yep.
How does it work in practice?
So a very good question. So let me repeat the question, because so I think the question was, when you put in place a platform like C3 at a customer, what do you need to manage the data in that deployment or in that setting? It's a great question, because the important part we emphasize is to ensure that there is minimal disruption with existing data systems, right? So I'll take a technical detour slightly. We deploy C3 in your cloud environment or your on-premise environment, right? So firstly, we don't expect that your data leaves your world, right? So just from a very high level IT security, like it's all staying inside RWE, right? It's not coming out. And equivalently for all of you. Within that, we then ask the second question, which is, have you already aggregated this data into something that looks like a data lake or some unified view? If that is the case, we can connect to that and use it. If it is not the case, then we can connect to individual systems, like SAP instances or anything else, in order to pull all of that together as well, right? And there's a series of things we work through with IT security and information security to create all of the permissions needed to do that. But at a very high level, we bring the software to your environment, so data does not leave your world. From an IP and data perspective, we don't take ownership of your data. You own your data. You own all the products of your data. So all of the insights, all of the predictions, all of that is all, we don't ever take ownership of that. And all of the data we try and minimize replication of that data as much as possible. It just depends on what we're doing, but that's kind of the idea. Did that hopefully answer your question?
Partly.
Please.
The quality aspect of
Oh, yes. Okay. So let me take that. So the other piece of this is everyone's worried about the quality of their data, right? And I always assure people, it's like your data are as bad as everyone else's, right? Like it's as bad as everyone else's, right? It's the same issues that you find on fat fingering some sensor data and you get 3 extra zeros, to the pi tags being wrongly coded, to files being mislabeled, to referential data being broken, like standard, par for the course. What we do in C3 when we ingest or process data is we look for what we call referential integrity, right? And so as we process the data in, we're checking for both whether things refer to each other, and we can force that relationship in. So it checks for it and says, hey, I can't find a match here, what should I do? We also have quality controls as the data come in. So if we find anomalous values, we can ignore the value. We can replace it with the closest alternative that keeps things smooth, right? And so on. So there's a lot of quality controls as we process the data. If you do those 2 things well, referential integrity and then quality as you ingest, it solves like 95% of data problems, right? Just fundamentally. There will always be some quirks that come up, and we'll deal with those as we do. So the other piece we do when we do predictions is we attach. So let's say you make a prediction that's dependent on 10 things, right? And you need each of those 10 things to be there, and then the machine learning model processes those 10 values and spits out a number, 75% likelihood of failure. We're able to contextualize that 75% alongside the availability of that data for that particular prediction. So we can say, look, the prediction likelihood of failure is 75%, but the data availability to make that prediction was 3%. So don't trust it, right? And on another case, it's 75%, but it's 95% available. You should feel good about that prediction and work on it. And we can show that to the user, which is very powerful because now you can actually make those decisions seamlessly. And so just various things we've done over the way because of exactly these issues. So, absolutely. So hopefully that gives you a little more color.
Thank you.
Please.
Yes. My name is Anna Maria, and I come from the more independent space. I don't work for a large company. I have been running my own smaller company in telecom for the past 20 years.
Excellent.
So my question is, how, in order to implement this very dynamic platform, what is the smallest size of a company? For example, can you get a return on investment if you implement it in a 50 million per year revenue company? Question number one. And question number 2 is, how do you actually measure success? Because we all get excited about ChatGPT-4, for example, and Claude 2. I do. But I end up staying up at night, every night, and actually I'm becoming, yes, but with good things, but on the other hand, becoming less efficient with other things because I'm so preoccupied with managing my new tasks.
Yeah.
And I imagine the same thing happens in corporations. Maybe you say goodbye to some people, but you become busy with other areas. So how do you actually count success, and how soon do you count the success? Do you count it in 6 months, in 2 years? Those are my 2 questions, because those would be
two very valuable questions. So let me just unpack them one by one. How small or large do we need to be in order to gain value? You know, it's a great question. I think the system itself is designed to be scalable. So we can go small or large depending on how, what kind of data we need to process and so on and so forth. In many of our cases, especially at the early stages of our deployments, we tend to make it so that there is a very low barrier to entry. It's like, let's just prove that this works, and the value you generate is commensurate with the cost of it. So it's not designed to be a very high fixed cost kind of game, right? When you get to the scale that's on the other end of that spectrum, then it's a different story because you're dealing with massive footprints across the board. So I don't think we would say that there's a minimum bar or maximum bar kind of thing. It's more around, is there business value that's in the tune of about a few million euros a year, right? And if that makes sense, then the ROI works out. If you're chasing like tens of thousands of euros a year, then we'd say, okay, you can do that with simpler tools, right? So that's really the question to ask. And that's an important consideration, because in many cases, our deployments, while they may be in large companies, they will start with one asset, which will look like exactly that size, right? It's not, and so the question is not, it's like, hey, what's the value we expect to get as we get into this? Your second question is actually tied to then, so if you believe that, then the question becomes, how do you realize that value? And for us, we think of this as a few different things you have to watch and measure, and we try and bake these into these applications, right? One is scale, right? Are you watching one piece of equipment or 100? Right, so that are you maximizing the footprint against which you can deploy the system? 2 is usage. Are people logging in and using the system across the board? 3 is machine learning or optimization outcomes. So this is, am I able to predict an equipment failure? Am I able to generate recommendations that make sense to an experienced operator? And we track that using feedback in some way, right? And so this is, you can track machine learning capabilities like precision and recall and those kinds of measures, but you can also track it based on user feedback, right? What fraction of the recommendations that were generated were reviewed and adopted? Right? Is a pretty strong measure of how good the system is in terms of actual use. And then 4th, we look at some operational KPI that should move. So for instance, over time, as you deploy the system, are we seeing fewer and fewer trips? Are we seeing fewer and fewer excursions that are unnecessary? Are we seeing fewer and fewer, or are we seeing yield improve for the same type of product over subsequent months across the board? We, at C3, we don't directly, we will put a number to it, but we don't. Eventually, the idea is to get to economic value. But the sequence is always scale, usage, machine learning outputs and value, business KPIs moving. And then if the business KPI moves, there is some value there, right? And so we try and tie those together. And a lot of this we can bake into the application, because I can track usage, I can track scale, I can track machine learning results. I can, in many cases, track operational KPIs. Hopefully that gives you a little bit more color.
Yeah, we'll continue later.
Please. Please. Okay. I'm around, so we don't have to stop the conversation here. But Laila, let me hand over to you, and we'll go from there.
Thanks, Adi.
Thank you.
Okay. So I'm going to double-click a little bit on what Adi mentioned as our reliability suite. I spoke with a couple of you during coffee, and it sounds like many of you are focused on maintenance, reliability, asset operations. So I will give you an introduction to what is our reliability suite, what is our version of predictive maintenance, what makes that different. I've included some customer examples, so how are a select number of our customers using this application at scale to drive that business value that Adi was talking about. And then I have a short demo video of some exciting new features, the new release of our application. This is an application we've been working with customers on for 10 years. So what does the latest version look like? And then when we break for coffee, I or Sid can provide some live demos of the working software as well. By way of introduction, I am Lila. I'm responsible for reliability and sustainability with C3. We've been with C3 for about 5.5 years. I'm trained as a chemical engineer and came from oil and gas. I worked at BP in my first life. So our reliability and sustainability applications that Adi mentioned, he already described in some detail. One additional point to call out is these applications are fully interoperable. So where we integrate data and we connect to your systems, deploy the platform, the C3 AI platform, into your environment, the data we integrate to a single application, the first use case that we get started with, is instantly accessible and reusable by the other applications that share that same data. So we find this is very, very valuable with the applications in this portfolio. typically we'll start with a very high value, very tractable use case, something like predictive maintenance, C3 AI reliability, which is what I'll show you in a second. This is typically a relatively straightforward business case. Many asset operators face unplanned downtime, are hoping to reduce those outages and improve the reliability and therefore improve the output of their plants, make their plants more efficient, get more out of their assets. So start with a very straightforward business case like reliability. Once we've integrated that data, get that system live, then it is very natural and much faster and easier to scale to adjacent use cases. So then you have the data in place, you have the software working in place, you can then scale to something like yield optimization or process optimization to minimize the energy consumed, et cetera. Using C3 AI reliability specifically, this is a small handful of our customers that we have deployed the application with and who are using the application at scale. What you'll notice here is it's across a wide variety of industries. The way that we've built the application, the way we have deployed and created what we call C3 AI reliability, this predictive maintenance app, is extremely reusable across industries. So even though the way that transformers operate and the type of data that you use to monitor and predict failures on a transformer and utilities looks pretty different than the failure modes and the way that a gas turbine would fail in an offshore production platform in oil and gas, it's actually the same plumbing, the same pipes, and in many cases the same machine learning algorithms that we can deploy for both of those very different types of assets. And then at the end user side, the application itself, the core workflows, the types of insights, is actually also very similar. A reliability engineer or a remote monitoring engineer is looking for the same type of evidence. When I predict a failure, when the application is, machine learning models are predicting failures, those users are looking for the same things. Why is that failure predicted? What are the underlying sources in the data that are predicting that failure? Is it a trend in a sensor? Is it a correlation to a prior failure event that we've observed in the history? And so maybe identify, what are those similar recommended prior events? What is the quality of the data, as Adi mentioned? Are there problems with the sensors? And then can I look at that? Can I really query, investigate, make plots out of it, time series charts or scatter plot charts? And then I want to go create a case or create a work order and take action with it and make sure that someone in the field is going to go and do something about this issue. And so that's the same general workflow, whether you are in industrial manufacturing, making paper, or if you're in utilities and monitoring transformers and circuit breakers. Our customers are getting some recognition from top analyst firms, so we're really proud of the work that they're doing. The customers here listed as a handful that are using predictive maintenance at scale, so just really proud of the work that they're doing. So what are the types of outcomes that we drive with C3 AI reliability? One is reducing unplanned downtime. 2 is increasing asset availability. 3, reducing maintenance costs. And 4, improving safety. So by predicting failures before they occur, you can intervene. And I'm excited to hear from Richard following our coffee break about how Shell is actually operationalizing predictive maintenance. It's a really common question that I get when starting to work with new customers is, today we work on a scheduled or planned-based maintenance routine, or we run to failure. We just let our assets fail and then we go and fix it reactively. How do I, as someone sitting in digital or someone spearheading this digital transformation initiative to implement predictive maintenance, how do I operationalize that? How do I convince the business stakeholders to proactively take action, or is the better outcome that they stage the work? Instead of just doing routine scheduled maintenance once every 6 months, maybe they want to gear up the team and say, hey, we're predicting this failure. You might choose to run to failure anyway, but now you have the right team in place, you have the right parts and materials, the spares all ordered, so that once that failure does occur, you can immediately triage it and you reduce the total amount of unplanned downtime. So there's many different ways that our customers are adopting and operationalizing these insights. It doesn't necessarily mean 100% of the time you proactively take a machine down and do something about that predicted failure. But it does mean that at the end of the day, you're increasing that asset availability and reducing the total amount of downtime. I'm going to just linger here for a second on the types of data that we integrate. So Adi explained in some detail that we connect to your existing source systems, and we're actually unifying across different types of data that you wouldn't typically include maybe in a single data enterprise platform to run machine learning models. So traditional data, so what you see in blue, that's really the operations data. That looks like time series measurements, it looks like control set points, work order history. If this is in a manufacturing plant, what is the production history and upcoming production schedule? So you know what are those raw materials that we'll be running through, because raw materials may have a strong impact on the operation of the asset. And then we also integrate the non-traditional data, what you see in green. And that looks like unstructured text, so documents or diagrams, like engineering diagrams like PNIDs that we parse using another AI form of machine vision to understand what is the relationship between any given sensor and its parent asset, what are the different relationships between assets. If I have a failure upstream, how might that impact something downstream? And so we unify that data and create basically a digital twin, if you will, of the asset in operation. What is the history of it? What are the failures that have occurred? What is the maintenance that has occurred? What is the metadata around it? Who is the manufacturer? What is the typical failure rate, the mean time between failure, as well as all of that contextual information about the diagrams, machine operating logs, maintenance manuals, et cetera. So I'll show a demo in a second, but before I do, I'll just give some examples of how this is actually working for our customers. So this is, just going back a second, this is a pharmaceutical manufacturer who came to us and said, we typically operate with scheduled-based maintenance, and their operations are very different than, say, an oil and gas customer, because they operate in batches. So they said, look, but if we have a failure in the middle of a batch, it creates a ton of scrap. And that is a huge amount of lost material, and we want to avoid that. So how do we, in our batch operation, predict and identify when the next batch is likely to have an issue? They were using some forms of monitoring, but those monitoring systems did not capture all of the upcoming failures. They only were able to identify the known events that they'd seen in the past and a certain subset of those known events. They didn't provide very much lead time. So we see this a lot in condition monitoring software where, yes, you may implement a condition monitoring system, but because it's based on either simple rules or hard-coded logic, it'll only give, at best, a couple minutes of advance notice. And with only a couple minutes, it's unlikely someone will notice that that alarm is running and that they'll actually be able to do anything about it. They had a hard time incorporating various forms of machine learning models. So we see some systems that do start to apply machine learning. One-class SVM model is a very popular type of machine learning, okay. But it's kind of a one-size-fits-all approach. And so if your asset or your operations aren't really well modeled by that one type of algorithm, then it's not going to work very well for your machines and for your equipment. And so they were looking for a system that was more flexible. How can I run thousands of A/B tests that compare and contrast the performance of different types of AI algorithms on every single asset, where I might have a unique model per individual equipment? Per pump, I might have a very unique model across 1,000 pumps. And that allows you to get much better performance of the model itself because it's highly tailored to that asset. Even if it's the same model of the same pump that is coming from the same original equipment manufacturer, it still might have unique operating characteristics because of the conditions that it operates within. And so being able to deploy those different types of models uniquely allows for much better performance. So this customer is looking for those types of benefits. They unified data, as I mentioned before, things like work order history, what were the different alarms and notifications that they had received, the batch reports, so what are those batches that they were producing, the prior system alerts, and then, of course, the sensor data, the monitoring data from the condition system. We trained and deployed, as I said, we run these A/B tests. So upon deployment time, when working on initial configuration of C3I reliability, we'll typically train, I don't know how many this was, this is 500 different ML model permutations, which then you train across every single asset and identify what is the best performing model for every asset, and then configure the user interface. We do this over the course of a 3-month project, and then at the end of the 3 months give you access to get to use the system and actually start training end users. So it's relatively quick to get started with C3.ai Reliability, and then as a result, really see the change to those operational KPIs. So some of the benefits that this pharmaceutical customer has now implemented is, this is really common, is just reduce the number of alerts that are generated per month. So many reliability engineers or plant engineers, process engineers are just flooded by alarms. I had that experience working in operations where you just start clicking delete on your email because it doesn't really matter. There's so many alarms, I'm never going to get through them all, so I'm just going to focus on when the operator is calling me, I'm going to focus on those issues. So instead, get much more precise about what alarms are being surfaced because those are the ones that matter. So this is a 90% reduction in the number of alarms that are being surfaced, which is very typical for most of our customers. I see in the range of 85 to 95% reduction in alarms typically. Second is an increase in the ability to successfully predict and identify failure events before they occur. So this is being able to notify those engineers before they start a new batch that there's going to be an issue and that they need to go do something about it before they start that manufacturing run. And then importantly, what is the lead time before the shutdown? It's only so good to recommend that, hey, there's a likely issue. If your good catches are still only minutes before that event, you still can't do anything about it. So being able to increase the lead time, going from a 45-minute, in this case, alarm, to almost 4 days of advance notice, makes it very, very actionable. You can actually go send and schedule a technician to go look at the asset, make sure that you have the right parts, and then go do something about it. So this customer started with us in the California area and then is scaling this solution across their various manufacturing sites. So they're starting with a single asset class. There are centrifuges, which is a really critical asset for pharmaceutical manufacturing as you purify biologics to produce some final drug. And then scaling with that starting asset across their plants globally before tackling their next asset class. A second case study, this is a major chemical manufacturer. So the challenges that they had were twofold. One is monitoring furnace health and optimizing decoking schedules. So furnaces are a very critical asset within their chemical manufacturing process. They had an existing furnace health monitoring solution, but again, it was very rules-based and univariate. So it just looked at individual sensors and said, all right, if this sensor goes out of bounds, generate an alarm. Certain sensors are more critical than other sensors. You can couple sensors and say, all right, if both of these sensors are out of bounds, that might be a more severe issue. But again, it's still rules-based and it's still reactive. And then second, their decoking schedule was time-based. So you decoke a furnace kind of gets full of crud as you run it because it has all of these impurities in the flue gas that you're burning. And so then as those impurities build up, that's called coke, and then it makes the furnace itself much less efficient. And so you're not getting as much heat out of it because you have this thickness building up on the inside of the coils. And so you have to go through this lengthy decoking process. It's like 10 days of cleaning. And they were running this pretty fixed schedule I think every 90 days. And so they came to us and said, how do we optimize this? Because if actually the furnace is running well and that level of coke that's built up isn't so severe, then we can keep running and we can maximize the run length of that asset and get more out of it. Because the more times you take it down for that scheduled maintenance, you're losing 10 days of operation. So they came to us and wanted to do both projects with C3.ai Reliability. Same thing, we unify, first step, unify, connect to their existing source systems, deploy into their environment, then train all of these machine learning models. In this case, we also added deep dives with their subject matter experts on a weekly basis as we went through this project. In this case, the coking models in particular were not something that we had done before with another customer. In order to make sure that, number one, those models are accurate, and number two, that those subject matter experts can actually do anything about it. Are they going to accept these recommendations? Are they going to have trust and belief in the system? How do we make sure that the application, once it's live, is going to be adopted? So we started that early with these weekly touch points with the subject matter experts, and then configured the user interface screens. What you'll notice in each of these case study slides, by the way, is that the user interface itself is very configurable. So because we have that platform that Adi was mentioning at the beginning, any one piece of the reliability application or any of our other applications is highly, highly configurable. That could mean, what are the source systems that we're integrating with? Yes, we have pre-built connectors. We very typically integrate with your enterprise asset management system, with your time series historian, with your work management system. But if there's another data store that we haven't integrated with before, we're very flexible. Our data integration layer allows us to connect to that source system. Likewise with the machine learning models, as I said, right? We have out of the box dozens of machine learning pipelines that we've seen work pretty well for the predictive maintenance use case, and we'll run through and train all of those models and identify the best performing models. At the same time, most of our customers now have data science teams who've been running POCs, and predictive maintenance especially is a very typical starting point for data science teams because it's such a proven use case. And so for those customers that have data scientists who've been working on this problem for some time, they may have a really highly performing model, but that model is sitting in a Jupyter notebook in some POC environment, and they haven't been able to scale and operationalize those models. And so being able to flexibly deploy those pipelines as part of the application is core to our architecture. And for some customers, they may have that perfect model for their most critical asset, for a critical steam turbine, but they haven't yet created those models for the rest of the plant. And so then you can mix and match. You can say, I want to use my golden model for my most critical asset because I've been working on that for 3 years. I just haven't been able to operationalize it. But then I'm going to use your out-of-the-box pipelines for the rest of the plant and kind of scale quickly there. And then finally, likewise, on the user interface, what you're seeing here is a highly tailored, highly configured user interface that's showing the coils in the furnace and different types of alerts that we're generating, because everything in the user interface is also highly configurable. So yes, we have all of these 3 things out of the box. Fully enabled, coming from C3.ai Reliability, data integration pipelines, machine learning pipelines, and user interface and workflow. But again, all of that is highly tailorable to your organization needs. So with this chemical manufacturer, again, we saw and have seen very strong results. So on the left-hand side, it's kind of a detailed look at that coking model and the forecast, as I was describing before. So being able to forecast what is the coking buildup on any given coil, the large deviation between predicted and actual observed. So in this case, the purple is the actual coking buildup, and the blue is the predicted buildup. And so once we start seeing those deviations between predicted and actual, we're sending an alert to the user to say, hey, look, we were predicting that your coking rate would stay relatively flat, but because of the way you're operating this furnace, because of the raw materials you're using, because you're burning at a higher temperature or higher pressure, you're actually starting to see much faster coking buildup than typical, and you're going to have to schedule that decoke event much sooner than anticipated. So as a result, number one is they've increased on average the run length of these furnaces. On average, they're able to use our application to not have such frequent decoke events, not do it every 90 days, but instead maybe do it every 100 days. And then the asset utilization as a result of that, combined with just predicting unplanned outages and unplanned failures on kind of the rest of the assets surrounding the furnace itself, increase the overall asset utilization. So one final example, then I'll show a quick demo and we can break for some more coffee. But with a particular oil company that we've worked with, this is an example where they actually have taken advantage of multiple applications coming from C3.ai. So they started with the predictive maintenance use case and then very quickly scaled to process optimization in order to get more out of their operations. So the primary pain point shown in red here is that they were rate limited in their production operations by their gas compression trains. And so they said, all right, if we're rate limited, really, we want to be able to get more out of those gas compression trains. One, by reducing the total amount of downtime, but two, we think that if we optimize the knobs, the set points of the operations here, we think we can squeeze more production out. So we deployed this application, and kind of cutting to the chase first in this case, we have demonstrated 2 to 4% increase in total production volume on these gas compression trains. And then two is, by deploying predictive maintenance, they're able to really safely make those adopt those recommendations. So they know that they're pushing the asset harder. The set points that the AI is recommending is kind of outside the historical operating state. They're now operating in a kind of a new regime that they haven't yet necessarily done before, but they're able to make those incremental changes, take the AI recommendations for new set points, one step at a time, make stepwise changes. And then as things start to deviate from kind of a really healthy state of the asset operations, and the risk to the performance starts to degrade, the predictive maintenance models are now flagging those risks and say, hey, you need to slow down, don't make those set point changes. We're identifying deviations in the health of the asset, and you need to monitor this or take action to avoid a failure. So in this case, almost all of the data that I showed before, it's identical to exactly what we deploy in C3AI reliability. So they were able to first deploy reliability, train up those machine learning models to predict failures, and then using all of that same data that they had already integrated, go deploy process optimization. It's on the same object model, it's on the same application foundation of that asset digital twin that we model in C3. In this case, there was maybe one additional data source, I think the production rate, because we want to make sure that we're actually measuring the production rate through process optimization so that the demonstrated results and feedback into the system are taken into account. So just double clicking, I'm not going to spend too much time here. Happy to talk at a break about this. And Sid, I know, is also very familiar with this use case. But how does this get operationalized? Because it is a little bit more complex than just predicting a failure and then having a maintenance work order that you schedule to have a maintainer or technician go and inspect an asset or make a repair. Implementing process optimization and changing set point knobs requires an operator to go to the control board and make those changes. And we needed to deploy this in a way that worked in concert with existing advanced process control technology that is a closed loop system that automatically controls set points in a plant. So in this case, we've started with a human in the loop approach. As the users are getting more and more comfortable with the AI, and we demonstrate that, yes, they're actually implementing the AI recommendations, then we plan to transition to a closed loop system. But in this case, starting from the top left here, the real-time data, so that's including the target set points, the actual observed measurements from any given sensor, and the production rate. Those types of data get fed into the C3AI process optimization application and underlying optimization algorithm, which then recommends set points for the operations. In this case, we're really focused on a separator within the gas compression train, recommend those set points, which get surfaced in a shift-wise recommendation to a process engineer who reviews that, and they dive into the evidence of the application. When that recommendation is surfaced, they decide whether or not they choose to accept or not accept, which is taken as feedback, and so we can measure the performance of those recommendations. If they choose to accept, it gets sent to an operator, and that operator overrides the APC controls in order to change the set points. We've seen this work very, very well, and we're measuring how frequently the operators are choosing to accept. So there's two different people that are having to accept that recommendation. First, the engineer to send it to operations, and then operations actually has to go and change those set points. And so one thing we've really focused on over the past 10 years of implementing asset operation software is, what is that evidence? How do you make someone trust an AI model? Because implementing a black box solution just doesn't work. And then I mentioned this at the beginning, and one thing we found is really, really important is the combined solution here, where when we recommend set points, we're also predicting the likelihood of failure on that same asset. And so that makes sure that not only are you surfacing the evidence of why is an AI model making a prediction, but you're also enabling a insurance policy, if you will, a backdrop of safety to say, if you make these changes to, in this case, this is the medium pressure separator pressure. If you change those set points, in this case, a user accepted the set points 4 times, the AI risk score, which is really faint, you can't see this on the right-hand side very well, starts to spike. And so those stacked bars are indicators of the risk of failure of that asset. So they started to accept those set points. We saw the risk score spike and said, hey, back off, stop accepting the recommendations. And those two types of algorithms are working in parallel, and those two insights are surfaced in a shared user interface so that the user knows whether or not they should keep pushing the asset, change those set points to run harder and harder, or back off because you're running the risk of failure. So in this case, we again saw really dramatic results, just focusing on the predictive maintenance use case. Number 1, reducing the number of alerts generated per year. This is a really dramatic reduction versus their rules-based condition monitoring system. Second is increasing the speed with which someone can triage an alert. Typically, if I receive some condition monitoring alert, I'm going to have to go and investigate what are the other sensors and alarms that are running at the same time? What might be correlated? I might pull that up in my own process historian and try to chart this out myself manually. I'm going to go and look up the standard operating procedures. I'm going to try to triage, all right, if I see these types of behaviors, what are the likely failure modes? Let me build out this fishbone and see where I need to troubleshoot. So making all of that data accessible and exposed kind of in a contained evidence package, if you will, just helps the user make that investigation much faster so that they can drive action very swiftly. And then finally, in this case, this customer was using 7 different types of monitoring applications, software tools, to come to the same result. So not only were the performance of the baseline worse, but they had 7 different software applications to try to get to these same outcomes. And so we're reduced the number of software systems that those users have to use. All right, so finally, I'm just going to go really quickly because I think we're short on time here. But a utility example, I saw a bunch of hands raised in utilities. So this is one of the largest utilities in North America. We've been working with them for many, many years. They've deployed C3.ai Reliability for transformers and circuit breakers across their network. So the scale of this is pretty massive. 350 different users. We're monitoring over 30,000 different unique pieces of equipment. Huge amounts of data and number of records that we're updating daily. So we ingest daily data and then predict failure of those transformers and circuit breakers. And for this company and many utilities, sending someone out in the field is non-trivial, right? Sometimes they're driving hours and hours, and so they need to have really advanced notice of when this type of work needs to be completed so that they can properly plan and schedule for it. So in this case, again, very similar story. We have identified basically a 48% reduction in number of events, of failure events that they experience. So actual events have gone down, so that operational KPI for the business has demonstrated a reduction in actual events that they're occurring. And our ability to predict those failures. So they previously were running on a scheduled-based maintenance approach where they just tried to go service as many of their transformers and circuit breakers as possible, but on a routine scheduled-based approach. And so they kind of scattershot, blindfolded, all right, it's been 10 years since I serviced this asset, I better go out and check on it. And so in this case, now they have a 98% ability to identify and predict which assets to go service, which means that they have a much more tailored service approach. So they're no longer telling their teams, all right, we're just going to batch-wise, we're doing this region this week, we'll go move everyone second region, or on a scheduled-based, time-based maintenance strategy. Instead, they're saying, all right, we know specifically this transformer is likely to fail, we need to go service it. And so it is a highly precise approach to maintenance versus that kind of scattershot approach. All right, so I'm going to show a demo video, and then we can show live software demos during the break. But I want to highlight how we are now incorporating the generative AI capability that Adi talked about into the application workflow itself. So yes, C3 offers a standalone C3 generative AI application, which is that Google-like search experience. But also we're taking advantage of those same APIs, of that same deployment architecture of the large language models to improve the performance and usability of our own applications. So in this case, what we're looking at is the C3 AI reliability application. So typical user would be a remote monitoring engineer or maybe a reliability engineer. They log in daily to see what are their most likely risks, where do they need to go triage and investigate what's going wrong. So in this case, we're looking at a gas compression train. We're seeing, all right, the lube oil system is really high risk. Oh no, I can't talk that fast. So I'm going to dive into the lube oil system. In this case, we're looking at one alert on the lube oil subsystem, and it's providing me the detailed evidence of what's going wrong. What are the sensors that are having issue? In this case, the lube oil supply pressure, the lube oil tank pressure. I could scroll down and see recommended failure modes because the application is looking at those failure mode libraries and giving indication of what failure modes are most likely to be attributing to this issue. My video paused. Is it still playing on your side? Oh. Yeah, it did. OK, we're back. So again, I'm scrolling down. I can see these top failure modes. But now with C3 Generative AI, I can have a much more interactive experience. I'm no longer just looking at the data, but instead I can query it and ask questions to make an informed decision about what should I go do about it. So I can click into this Ask C3 Generative AI option. I click Start a New Chat, and this opens the chat window like you saw before. And in this case, maybe I'm an inexperienced operator, like Adi was talking about. There's been a lot of turnover. I could ask, what's wrong with my lube oil system? And in this case, it's giving me a summary. The lube oil supply pressure is 31 psi higher than the predicted value and rising. So we're showing what did the AI predict the sensor value should be versus what is actual. And I can kind of understand where is this coming from. The source in this case is the time series data source. It's not coming from a file. It's coming from the actual observed sensor historian. And then I might be wondering, OK, well, that's great, but is this critical? Is this still within my operating bounds? Or is this starting to be abnormal behavior? Keeps pausing, no?
It's moving.
It is? OK. Give some feedback. Yes, I think this is a good insight coming from the generative AI model. Yeah, I think it's the video is getting stuck. In this case, we're applying the generative AI models to both the structured data and the unstructured data. So in this case, what we're looking at is an example of summarizing and surfacing information coming from time series data. And now we're applying the same generative AI model and search capability to combine it with unstructured data. So now I might ask, the normal operating bounds for the lube oil supply pressure are 25 to 80 psi. And I can see what is the upper limit and the lower limit, compare that to the actual sensor values that we have available. And then it's telling me where is this coming from, in this case, the Sailor's Pocket Guide. So it's reading those upper and lower bounds from the pocket guide for this asset, so like a equipment operating manual. And then it's surfacing that on a chart overlaid with the time series data that's available. So then I'm now satisfied. I've kind of investigated the evidence of this alert. I think that it is real. I'm going to go and create a case. So now I've entered into the case experience of the application. A case is where I can really collaborate with other users. I can upload files. I can leave comments. Maybe someone goes and takes a picture. They'll upload it here. I can see what are the other similar events and alerts that have happened in the past, kind of all contained in this central workflow. So now within C3I reliability, we had this case experience, we've had that for many years, but now we've introduced this generative AI capability. So again, now that I'm working within a case, I really want to know, what should I go do about it? Yes, the alert told me there's an issue, but I need to know what actions should someone take in order to prevent an upcoming failure. So I have the top failure modes. Those are being recommended from the application, coming from the failure mode libraries, what's most likely correlated. I could see, all right, this could be a lube oil problem, a bearing problem, a cooler temp controller problem, but maybe I just want to be spoon-fed. Again, I'm that new operator. How can I troubleshoot the lube oil supply pressure on the lube oil? Because that is the most contributing sensor that is deviating. It summarizes, again, this time coming from an operating manual. If the lube oil supply pressure is high, you can do the following, and it's giving me a summary of what is that standard operating procedure, and I no longer have to go look this up in a file store. Most likely, people don't even want to read it because it's pages and pages. It's like opening your car manual from your glove box. It's impossible to find the information you need, so let me just ask it here. I've already been focused, the application is focusing me on not only the most important asset, but the most important failure mode, what's driving that prediction, and now I can just go and ask and quickly identify what should I go do about it. So I'll pause there. Again, we can give some live demos of C3I reliability or other applications, chat more over coffee. But if folks want to stick around now before breaking, I'm also happy to take some questions. Yes?
Well, thank you for your presentation. I was wondering, you talked about a failure mode library. So typically when I think of failure mode libraries in our company, it would come from FMEAs. Where do you get the failure mode library?
Yeah.
And is it automated, updated by the AI? So if there is a new failure mode, does it get fed back into the library so that the library gets bigger, or how is it done?
Good question. So for the first part, where do we get our failure mode libraries? We have in the application, from our experience with other customers, a couple dozen what I'll call asset templates. What is the operation of a pump? What are the expected sensors to see on that pump? What are the different failure modes and root causes of those failures for that pump? For some customers, our asset template library is sufficient. In other cases, even though we might have that failure mode library in our repository, maybe you come with other failure modes you want the application to model. So then we'll ingest your failure mode libraries, kind of incorporated into the design of the model itself upon initial implementation and configuration, and so we can augment our failure mode libraries with yours. In other cases, we might be configuring the application for a completely new asset type we've never seen before. It's a highly specialized piece of robotic equipment for your manufacturing line, and it's kind of fine-tuned to your operation. In that case, we'll work with you to look at the format that you have your failure mode library in, and then we'll ingest that and kind of rely on your source system to be the source of that failure mode ground truth. Now, for the second part of your question, how do we learn over time? The application has many points of feedback. I didn't go through many of the workflows and screens just now in that little video, but we incorporate user feedback at many points of that workflow. So, thumbs up, thumbs down, is this a good recommendation, bad recommendation? Or thumbs up, thumbs down, we missed a failure. And if we missed a failure and it's because, it wasn't, the machine learning models weren't trained on enough data to be able to anticipate that failure, then users can give that feedback, and then we'll retrain the models in order to incorporate that in over time. So there is kind of a reliance on users to be giving some feedback, or we just typically our retraining schedule would be about once every 6 months. So then you could wait for the kind of routine retraining in order to capture those new failures. Yes.
Yeah, on that training of that model, to what extent do you use historical data, historical process data, and how do you single out the relevant events for that particular model?
Yeah, we do use historical data. It's not required to get started with C3I reliability, but we typically like to train our models on roughly 1 to 3 years of historical data. And then through that configuration project, we'll sit down with your SMEs when we're maybe a major turnaround event that would have been a massive regime shift, and we need to kind of treat those time periods differently. Or what are the periods of outages that we need to mask out? And so we'll exclude some periods of data when training the models. And so we work with your SMEs to understand that initial history. Now, if you don't have that history, then we can get started with basically an anomaly detection approach. So deploy really simply trained models. If there's only, let's say, like 1 month, you just deployed this censoring technology, you've just set up your historian system, then we'll just deploy pretty basic anomaly detection models while we collect that data, and then we'll retrain those models over time. All right, so with that, let's make time for coffee, and then we'll return back to hear from Richard and have further Q&A.
So I'd like to extend a very warm welcome to Richard from Shell. He'll introduce himself, and he will be talking to us about the journey to today and future plans of Shell in reliability and predictive maintenance. So thank you very much, Richard.
Thank you. Hi, good morning, everybody, and thanks for turning up here. You get stuck with me for the next half an hour, and somebody just please shut me up if I start talking for too long, because it's been a 5-year journey with the predictive maintenance, and I've been there since the beginning of the start of this in Shell. A bit of background about myself. I've got 20 plus years in the oil and gas industry at Shell. Before that, I was in optimization. My time in computing goes back to the dark ages of punch cards and tapes. So programming and assembler was my thing. So when I look at C3's program and how many millions of lines of code they've got, it really worries me about how inefficient we've gotten these days. But it's been an interesting time. And I'll go through a bit of the journey of how we got to where we got to. A couple of things to start with. Definitions and cautionary notes, and feel free to read the small print. Suffice it to say that anything I'm going to say here doesn't reflect on Shell's performance, current or future. Cannot be construed. Please don't take this to the markets and say, oh, Shell's doing a fantastic job, going to invest, and then come back and ask me why we didn't perform. This is purely around the predictive maintenance and has nothing to do with our financial performance. Where did we start with this? In 2017, and I'll go back to why we started with this. For those in the chemicals and oil and gas industry know that if you go and ask an engineer, how can I improve my maintenance? They'll tell you that they can create a fantastic white box model. It's only going to take them 3 years to build, and will need constant maintenance and could have a team of 10 people to continue to look after that. We realized that we couldn't do that across our landscape. When we talk about the number of valves and critical pieces of equipment, we're talking the orders of hundreds of thousands. And to do that would require an entire company just to look after these. Not to mention the fact that we've talked about experienced engineers, what we call the big crew change. Youngsters these days don't want to work in the oil and gas and chemical industry. They'd rather become influencers and TikTok merchants. It's much cooler than working in this industry. So we need to retain the knowledge, and we need to do it better, faster, quicker. We need to get better about what we do. And at the same time in Shell, safety is our top priority. So no harm to humans, no harm to the environment, and ensure that we are keeping things going well. So we said, how can we do this? And we started off with a grad project with Delft University, looking at how we could apply statistic modeling to try to determine if we could predict equipment failure. It was fairly successful. And it was applied across a number of known failure cases in the past. We looked at compressor for one of the compressors on the offshore facilities in the North Sea, and the same applied there. So we said, okay, there's a basis for this. But that in itself was just the starting point. We said, okay, how can we grow this? And somebody came along and said, talking of data and data quality, somebody said, well, we've got 2 million valves in Shell. How are we going to go from 2 valves to 2 million valves and do it in the next 6 months? that was a challenge I was given. I said, that can't be right. We did some checks on the numbers. It turns out we've got around 5 million pi tags. So for those of you who use OSIsoft or Aviva, we've got 5 million of those across all our assets. Currently today, we ingest and we generate data at the rate of around 15 million data points a second. C3 has had the arduous task in the fights with me about having to ingest this data at rapid speed and process it. So how do we get to that growth? So we started off an accelerator on that. And we got to 32 valves after a period of time. But we missed a whole lot of the basis and the underlying pieces to how we would manage orchestration, how are we going to manage the data normalization, how do we deal with data quality, how do we deal with missing data, how do we deal with not building a bespoke solution that is only applicable to one asset. Adi got a knock on the door, I think, when we were working in Australia on another project. And we gave them a challenge. We said, take these, replicate this, and show us you can do this for 500,000 models. I think he scratched his head and said, what? So it was a good challenge. We went through that with analysis. Yes, they proved they could do it. Yes, we proved we could do it as well. And we started working that. So at the end of 2018, we said, OK, we'll work with C3. This gives us the best opportunity to take advantage of moving forward rapidly from where we are today to scale this up to the order of tens of thousands of models. By the end of 2019, we got to a massive 100 models live. So it wasn't all smooth sailing. But at the same time, we took our knowledge of the C3 platform, of building applications on it. C3 at that stage, Adi, correct me if I'm wrong, 200, 250 employees max, I think it was. And we had nobody with any C3 experience in Shell. So we built up a dedicated team. We learned on developing the application. We needed a cross-functional team. This was not a technology or an IT-led project at all. It was baked into the business process. So there was a lot of stakeholder engagement around the change management of how to improve the process, bring the engineers along with the journey, the control room operators who can be grumpy at the best of times, ensure that they are on board with this because it's not a technology that we're going to put in to say, thanks very much, but we don't need you anymore. We couldn't afford a risk of a failure at a plant that was catastrophic. There is no way we would put people in harm's way. So we had to ensure that what we were doing was, let's say, well thought out and well maintained. In 2020, we started focusing on replication. And we scaled back from our original intent of trying to cover the globe from the west coast of Australia to the west coast of the US all at the same time. For those who've been around long enough, might remember an Accenture advert about building airplanes in the sky. Yeah, it doesn't work well. We scaled back, we focused on one asset, we got it right on one asset, we brought people along with that. We focused on identifying small areas of failures with a mantra of sort of find small, fix small. There's no point in trying to look for the tens of $1 million as your first example and go back to senior management for more funding and say we found these huge problems. Look at the small ones, celebrate those successes and move forward on it. We expanded out in 2020 where we'd proven that we could run this at scale. I think, Adi, you mentioned as well, we're at some 28 assets now, some 50-odd applications running across the space, covering numerous areas. In 2021, we got together with C3, Microsoft, and Baker Hughes and formed this OAI initiative and said, the days of old where we used to build solutions and keep them under lock and key in Shell and said this is proprietary technology, we are working more collaboratively with the marketplace. We realize there's benefits in working together. We do that in the subsurface world under things like the OSDU agreements. And also get inputs of other people as to what the problems that they're facing. So that was the intent of that. We expanded the compressor module out to what we cover as critical equipment. So we now cover turbines, compressors, and pumps. both reciprocating compressors and centrifugal compressors. And we started taking a centralized approach. So experienced engineers are difficult to come by. They are retiring, they're leaving, they're going places. Thankfully and hopefully generative AI is coming along. I don't know, we'll see what that brings. But we set up centers in India, which we call our technical asset operations. And they do most of the triage and monitoring for us worldwide. So they're the first port of call. An alert comes in, they pick it up, they assess it, they pass it back to the plant and the asset where it's needed. If there's something to be acted upon, that's then put into the work order, and so the work carries on. We extended out our control valve application to cover other pieces of equipment as well. So taking the basis of what we built out for the reliability application there, we found that we could apply the same logic and the same algorithms to other equipment. Why was that of benefit? It meant we didn't come up with a new solution. We didn't go off and build another solution. We didn't have to evaluate it. We already had the basis in place. All the data and the applications were there. Some minor changes to it and some immediate benefits. Back in 2022, 2021, I think these were all the challenging years when COVID was around as well. We also were fortunate. We got awarded a Manufacturing Leadership Award for use of AI in the industrial space. Again, this is quite an accolade, given that this was the sort of first time that AI had been considered in this, where traditionally, if it wasn't a fine engineering calculation based on thermodynamic libraries, it wasn't considered. But people started realizing that things are changing, and we've got new things on the way. In 2023, so this past year, what we've done so far is we've tripled services with value. So it's all fine generating an alert, but if there's no action coming from that, then is it a genuine alert, or is it something that actually was worth seeing in the first place? Where we've got services with value, that means that somebody's physically gone out and done something to a piece of equipment which has added value into the system. So we're increasing our number of services, at the same time reducing the number of false alerts. We did a deal with C3 where we've transferred our intellectual property for the centrifugal or the critical equipment application and the application for control valves, so they'll incorporate that in there. Part of the reason that we took our approach, as I mentioned, was how do we scale up very quickly? And if I have to build a model from the ground up by going through my data, which is inaccurate, unstructured, irregular at best, and I need a subject matter expert who's got detailed knowledge of the plant and all the P&IDs, I'm not going to get to the numbers that we needed to get to. So we took a different approach with the control valves, the way we do it with correlations and creating the models and automated training and bulk training. I think to date we've trained about 1.5 million or 1.2 million models. And we have over 20,000 currently running on a day-to-day basis generating predictions. And that number's continuing to grow, as well in other areas. The solution is now business managed. It's been handed over. It is in full-blown production, and we continue to use it and grow the capabilities of it. What did we learn along the way? First off, identify the problem we're solving. There's no point in saying, I've got this wonderful AI tool. What can I do with it? Let me think of something weird and wonderful to solve. Take real-world problems. We said we had trips were our biggest problem. The two biggest areas were compressors and valves. They were costing us money for deferred production because a barrel produced today is worth more than a barrel produced tomorrow. And in the downstream side of the world, if we shut down a plant, it's in the order of millions or tens of millions a day. We knew those were issues. We knew we had to solve them. We knew we could get value from them. So we focused on that. Product development and replication are different. Yeah, developing the solution with an asset with the subject matter experts is not the same as replicating it to different assets. Our assets have grown through acquisition organically. We've got a mixture of brownfield assets, greenfield assets, assets that have been around for 50 plus 60 years with all various levels of quality of data. The tags are named with naming conventions, no naming conventions. In English, Dutch, German, Cyrillic, you name it, we've got a combination of them all. So we need to be able to take what is in an asset and actually use that data. Asset hierarchies are not the same all over the place as well. They've changed. We've had to work a lot on the data. So one of the first things we do is a data quality assessment as well before we go full scale. Or we start fixing or normalizing the data so it's usable. Build on existing products where possible. Yep, we started the journey in 2017, and we didn't change a lot from there, other than use C3 as the platform to do it. We've taken the control valve application and applied it to other instrumentation in the refining and the upstream business. We didn't rebuild. We didn't change the application, the basis of it. We kept the original state of it. Replicate only when the product is ready. Yeah, don't build an airplane in the sky. They tend to fall out of the sky. So you need to have the base minimum functionality. Waterfall methodology is all fantastic and great until it doesn't work. That's the quickest way to lose your stakeholders and your funding. Embed the product into a work process. This is not a technology-driven product. It is not an IT-led product, and it is not an AI-led product. This is a real business problem that needs a real solution. And if it's not in part of the process, it's an afterthought, and it's not accepted. So change management is absolutely critical to this. Scaling required internal and external partnerships. Yeah, external partnership, C3. This is where we partnered with them. We needed them to get there. Could we have gone a different route? Yeah, we could have used Amazon, AWS, Google Cloud. We could have gone Azure ML. At the time, we're going back 5 years, they were all at different levels of maturity. So our best option was the option that we chose. Our outcomes, what did we end up with? We ended up with an enterprise platform. Does that mean that C3 is the only platform for AI we use in Shell? No, absolutely not. We have data scientists working day to day using Python, Jupyter notebooks, all sorts. We're not going to stop that. That will continue on. If we look at the federated sort of community data scientists we've got across Shell, in the order of some 4,000 people. That could be anybody who's working as an engineer at the plant, who's got some data sciences, who wants to try something out, who does a sort of build your own application on site. Those we'll look at, and some of those then mature up the path and become an enterprise solution. Some problems are unique to a given asset, and obviously we won't invest the time and effort in building an enterprise solution for that. AI Competency Center. We've grown the Competency Center so from 0 staff and people in the space of building enterprise AI solutions. We built that capability to over 50-odd people directly involved in delivering the solution, to some 200 people if I take the extended people on the change management engagement, the people in the assets, the people in the technical asset operations that use the tool, that provide the feedback to us as well. And that's continued to grow. Global deployment and adoption. Where we look at it, and I think also when I joined Shell some 20 years ago, I remember working optimization and got told the first thing when we're dealing with some supply optimization that somebody said, oh no, you don't understand. The business in Australia that we have is entirely different to the business in Europe. It's not. We produce oil, we produce end product, and we ship it to a customer. Yeah, fundamentally, it's the same process. So where we can build out them, and we built out one single solution. There is no customization. Each plant hasn't got its own version of this solution. There is one centrally hosted application in Europe that is used globally. The models are all different, but it's the same solution. Increased availability. Increased availability of our assets. Obviously, this has all led to equipment uptime, allowed us to continue operating our plants better, Some of the things like our remaining useful life in the products that we've got baked in allow us to assess the degradation or the rate of wear on parts of the equipment. We know that we can extend the life of that out to a planned maintenance activity or a scheduled maintenance activity. So that allows us to change the process to ensure that we can keep running, rather than have an immediate failure problem where we have to shut the plant down, do a break fix, and carry on again. Ongoing value realization. Yeah, we have to continue to realize value. It's a very difficult one, and I'm sure you've got the same problem. When you want money for investment, you've got to measure the value you're getting from it. How do I measure the value of an asset that's got no failures? Uptime. So it's a balance, though, because then my value is 0, but my uptime is 100%. If I get to 100% uptime, I'm doing fantastically. But people still want a dollar value attached to it. So we do measure that with the assets. It's not a number that we centrally generate and dream up. It's not an NPV calculation. It's based on real outage activity that we would have incurred and maintenance work that would have had to be carried out. It's supported by the assets, by the engineers themselves, and we report it accordingly. I'm not going to read through the text on this one, but these are just a couple of examples of some failure cases we had. One was around a control valve. There were some deviations on it. If we'd had that, we would have had a deferment, and I can't mention the number of barrels equivalent, but it was a fairly significant outage that could have occurred. So these things were an early finding that was put in there. This piece of equipment wasn't scheduled to be maintained during a turnaround activity, but it was subsequently added to the list, and the defect was addressed, and then startup ensued, and so normal operations carried on. Critical equipment, yeah, pumps, compressors, wonderful things, require lubrication, have bearings, bearings tend to fail, gas seals fail, all these kind of things. When those do, they're either catastrophic, it's fairly cheap to replace a bearing, it's very expensive to replace your entire compressor, particularly if it's a big one. And not to mention, when we were discussing it a little bit earlier, before this all started, we did have an incident somewhere where, through fortune, we happened to have a spare compressor of a very large size at a given facility. If not, there would have been an 18-month lead time for a replacement. And that's shut in production for 18 months. So you can do the maths on a large asset, what that would equate to. So these things are what we focus on. Early detection of anomalies reduces our unscheduled deferment, unplanned downtime. That's a given. That's all the plants want to do. In the good old days, a refinery manager was tasked with run the refinery at 100%, produce as much product, spit it out the other end. I don't care if you need avgas or mogas, just produce. We've changed that around in the business these days. It's more a demand-driven supply chain. We know we can make changes to the product production. We can improve our avgas or mogas depending on the time of the year, depending on travel patterns, depending on needs. But one thing does remain, we need to keep the plant running and available. So that's where we need to run. Do we reduce our maintenance costs? Timely intervention, yeah, catastrophic compressor failure is far more expensive than replacing a bearing. I won't get into contracts with General Electric or Baker Hughes, but quite often, so if anybody's used Predix in the past as an example, or got contracts with some of the equipment manufacturers, if you say we want a 99.9% uptime, they will come in on a Monday and say, by the way, we need to shut down compressor 235A because it's going to fail. And you say, well, no, we're in a critical production stage. And they say, well, no, to keep your uptime, we have to shut it down. We don't care about your production. We're in control of our own destiny now. We recommend when to shut down. We recommend when the maintenance activity carries on. Use AI to find small and fix small. Yeah. Fix a problem when it's small before it becomes big, because when it's a big problem, AI is too late. Where we are in the product space at the moment, and this has been a journey, I would say these are the products we've got live and in production. Coupled with this are numerous proof of concepts in various areas, covering the upstream, downstream integrated gas, and the renewable space as well. So we're continually evaluating where there are additional use cases to apply AI and AI solutions. So real-time process optimizer is used in our LNG plant, and Lina touched on that a bit around process optimization and incorporating that with predictive maintenance. If you can improve your process by the order of 0.5%, 1% in terms of dollar revenue values, it's considerable. Corrosion and risk modeling and analytics, a product we call Karma. Corrosion is a problem. We deal with products that have a lot of water in them, have a lot of sulfur in them, have a lot of corrosive materials in them, H2S gases. And some of the plants are all covered with cladding. And to discover corrosion under cladding is very difficult, near impossible to see. So we use various methodologies as well with an AI tool, also built on C3, to assist us in that space. Autonomous integrity recognition is a machine vision use case that we use for evaluating the plants when we're doing inspections. So we'll go off and take a whole lot of drone footage. We'll send inspectors around. They'll take photographs around the place. We have a number of use cases we can apply that against, and we measure against that as to previous known issues. So we've identified a number of areas where we've picked up anomalies with that, but also reduced the inspection time and turnaround, which is a sort of cost saving. Operator rounds by exception. This is a robot we have running in a number of plants, going around doing inspections. So this is part of the HSSE side of life, taking people out of harm's way. We can take a physical person out who has to go and walk around in miserable snowy conditions, blizzard conditions, whatever it might be, or extreme heat conditions. And the robot can go and do the work to evaluate, read gauges, check meters, ensure there's no leaks, listen for sounds, and respond accordingly with feedback. ESG is an area that obviously is keen on everybody's mind as well. This is something we're looking at and evaluating right now. And Shell Remote Sense is a product we've built which is equivalent to a lube analytics product, but using AI to determine properties and replacement of lubricants. How am I doing for time? Any questions?
One problem I see with predictive maintenance is that in view of change management, that there are no kind of heroes anymore. I mean, if you change your things before they fail, there's no one who can stand out and say he's the hero. He managed the situation, and it's if everything is running smooth, there's no how would you say? There's always the question: why do we need preventive maintenance or predictive maintenance if there's nothing failing? You know.
I 100% agree with that one. There's a couple of things in this one, and it's if you go to an asset as well and you say, well, we're putting this fantastic solution for your predictive maintenance, they go, yeah, but we've got 20 other programs we're running at the plant with real asset engineers day to day optimizing and making things better. So we already knew these problems anyway. If we reduce that, the next problem that comes around is the asset's budget for their maintenance activities gets cut. And they don't like that either. Change management is absolutely key to this. You have to bring the people on the journey. And so what we do is, again, it's around celebrate the successes, find small, fix small. And it isn't about, yeah, we found a problem that was worth tens of millions of dollars. It's a problem that we said we avoided $100,000 in cost, or a $20,000 replacement activity. And keep celebrating the small activities. Reward the teams, highlight the members who worked on the problem, who saw the issues. And it's continuous work in that space. And it's not going to go away. The minute you stop doing it, the interest goes away again, and you're back to where it is. The quickest way to see if it is working is to stop doing it and look at your reliability. The problem is nobody wants to take that risk. We're not going to take that risk. If it is applying, is delivering the benefits, we're going to keep doing it. But it is hard to justify when you're spending money and you've got 100% uptime.
Richard, thank you for sharing those learnings. That was very interesting. In terms of bringing this to the business, do you use a push or a pull model, or is it a bit of a combination of both?
A combination of both. So it started off as a pull. So somebody in the asset space turned around and said, by the year X, we're going to have, our goal is 0 trips. Yeah, very ambitious goal, because we know that's near on impossible. Even on a brand new greenfield site built from scratch, you're going to have problems and outages. So it started with the pull saying, that's our big, hairy, ambitious goal. 0 trips, we know that that's going to lead to X dollars in value around reduced deferment and increased production. And then we said, okay, let's look at that and evaluate how we can address that. The 2 biggest contributors were control valves and compressors. We said, okay, we'll build a solution out for that and prove that we can actually do something. The next step was how do you scale that without using discrete first principles-based engineering models or white box models. And that was the way we said, okay, we can scale these faster than you can build, a single model for one piece of equipment at a given asset. We can do it for multiple pieces of equipment for the entire asset. So it's a combination of both, absolutely.
Okay, well...
We've got one more over here.
So do you see sense in applying those concepts in an industry where you have smaller assets and batch-wise running assets? I mean, the thing is, you have your really big compressors. They cost a fortune to keep a spare compressor. So you can really stuff them with sensors and things like that. But where I come from, we have the problem we don't run continuously, so that we always have ramp up, ramp down, or maybe just do other products, so multi-product facilities. And our assets are much smaller. So when we talk about pumps, they are smaller pumps. So we would need more, way more sensors, and they are more easy to replace, less cost of keeping spares. What would you advise on doing with AI and predictive maintenance?
I don't think there's a right answer on that one, my opinion. And in fact, actually, another national oil company, the way they run their equipment is they run it as hard as they can for as long as they can, as fast as they can until it breaks. So they operate on entirely different conditions. To them, they don't really need to predict things. What they need to know is they're just going to run it flat out. We do have small pumps and small compressors as well. There's also entirely different parts to our plants. The intention is to look at this and say, where we have critical equipment that could lead to let's say, the entire plant being shut down, that is something we would like to monitor. And what is critical is quite often difficult to see. So back to the data and data quality. I can go through and I can look at criticality in my SAP system on our on the plant management systems. And there are pieces of equipment there that people say that's absolute nonsense. That isn't a critical piece of equipment. An effluent valve, for example, that's a relief valve. Somebody says, well, that's just not critical at all. If it goes wrong, and we suddenly dump a couple of tons or 100 tons of hydrocarbons into the Rhine River, it's a very critical valve. It's not critical, but it is critical. So you have to make those decisions as to what applies. And you can run smaller AI models that, give you the same results, or it doesn't have to be a massively scaled solution. What we're doing as well, we've got a lot of older assets. If we took the Rhineland refinery or Pernis refinery, we're adding instrumentation to it and sensors to it. LoRaWAN sensors, wireless sensors are becoming far, far cheaper. We don't have to worry about APEX or ATEX approvals for these equipment. They're already done. In the past, to add a flow meter to a pipe in a refinery was probably in the order of 20,000, 30,000 plus, assuming all the rest of the infrastructure was there for it. Today, you can do those, for the order of 1,000. So It is changing. We're getting a lot more data. There is more and more data becoming available, which leads to better models, better predictions, better ability to react. New pumps, new compressors, they're coming already pre-censored with all the availability of that. So it is changing and will continue to.
Question, did you also observe some examples where you maybe had to increase the budgets?
Where we had to increase the budgets?
Yes, to realize the total performance.
I don't believe so. So we've stayed within, I think what's happened in some of the assets, we've actually reduced the spend on maintenance activities. Where we've taken out certain activities, such as planned and scheduled, every 6 months you're going to go and work over a piece of the plant. We've realized we don't need to do that. So that activity can be taken and the money that was being spent there could actually be utilized elsewhere. Pre this, even I can say, this is something we've been looking at for quite a while. So an ESD device at an offshore facility, an emergency stop device. We had I think historically years back, we used to say every 3 months or every 6 months you had to do a full test of that to ensure that, when that kicked off, the entire facility shut down. That meant every 3 months, every 6 months, you were stopping an entire offshore facility. You were shutting it down. You had to do the startup all over again. There was all that lost production all the time and the risk. We then started collecting data on that and said, well, instead of doing it every 3 months or 6 months, we can actually, the historic failure of these things has been so long that we can actually do it every 2 years or every 4 years. There's no need to do this every 3 or 6 months. And you can go back to the sort of the governing bodies around us and saying, this is the proof that we've got to say that we don't need to do this. So we're not running a risk of a catastrophic failure. We can actually prove with data points that these things are unnecessary. It's other ways to look at it is saying, we focus on an area of the plant. We still got our turnarounds and workover activities for the plants. We process corrosive products. We know that you have to replace certain things. It's going to happen. But what we can do is, while we've got a shutdown in an area, we know that a piece of equipment that may have an issue, we can bring that in for a service activity that wasn't planned. And that saves us money because after startup 2 months down the line, we don't have to go shut it down and start up again.
Thanks.
Okay. So at this point, we have about half an hour until lunch. So if I could invite Adi and Laila, if you could bring your chair. And we'll just put it up in a semicircle here on the stage, and we'll have a fireside chat. I've got a few interesting questions around the topics that we've been talking about, and really interested in feedback. Thank you very much. So my first question is for Adi. So ChatGPT was introduced about a year ago. It has changed our lives in some respect. I know I use it a lot. How has generative AI and this new general interest in AI changed the landscape for industrial companies? And the reason why I ask is everyone has a digital roadmap. There aren't many companies out there who didn't have AI on their digital roadmap. And so should customers be prioritizing generative AI initiatives over more traditional AI initiatives?
That's a very binary question. Let me step back. If I look at what has changed over the last year with all of the generative AI capabilities that are being launched, two things are simultaneously true. One, it is a revolutionary technology. Just the way the capability includes and is able to allow a human to interact in a pretty conversational tone with a system. It is also a lot of hype. I don't think people have figured out yet how and where to use it for the most value. So every consultant has a report out there that says this is like tens of trillions of productivity, and there's a lot of multiplication on top of multiplication, right? But I think at C3 at least, what we're seeing is if you can't tie this to something that allows a company to genuinely make money, better, faster, cheaper, then it becomes a high-level productivity tool like faster email or faster PowerPoint or faster anything else. And that's fine, but if you really want to move the needle from a business value perspective, you have to find a way to tie it to some sort of business outcome, right? In the way you operate and so on. And that, frankly, I think we're just scratching the surface. I showed you a few examples, as did Laila. That's early days, right? We're able to now look at documents plus some telemetry and answer some basic questions. I don't know where this will go, frankly.
Okay, so your answer is tied to business value, and where the value is greatest, that's where you should focus. Okay. My next question is for Richard, and it's sort of building off Adi's earlier comments. You've talked about the AI initiatives that you have in Shell, Karma, and corrosion under insulation and cladding, robotic inspection support. You also spoke about leveraging time series and computer vision AI models for inspection and also operational safety. How does generative AI fit into all of that? What opportunities do you see leveraging generative AI, natural language interfaces on those different applications that you've developed?
I think Adi answered that, where the business value is. It's an area that we're obviously looking at and evaluating, and we'll continue to look at where it makes sense to apply it. And I think the great thing is, if I go back through my era, in the 80s there was talk of AI and AI solutions. The computing power just didn't exist to enable it. We're the next wave of that cycle, and there is going to be a sort of an inflection point where it sort of loses a bit of the spark and the interest. But we also face, as I mentioned, the sort of big crew change or the shift change, where the older experienced people are leaving. How do you retain that knowledge, and what do you do with it? You can't put it in a document or a 500-page procedure or a manual and expect somebody to pick it up and read it and understand it from day one. We work in a multinational, multicultural, multilingual society where I might write something really prosaic in English, but it's not going to be understood by somebody whose native language is Hindi, for example. It doesn't make sense. So, we've even seen that things like pictures actually are far better instruction manuals than verbose text that cover a couple of hundred pages. And we will try to incorporate that going forward into things like the predictive maintenance. We've got augmented reality for workers, where we can provide deep expertise from a central person, which are extremely rare resources at a central location. And it doesn't matter if he's working something in Fort McMurray in the freezing cold in Canada or in the middle of the desert in Oman. But they can also provide that, they can see what's going on, they can refer to documents, manuals, pictograms, etc., but also applying Gen AI to do that. So when they run into a problem and say, I'm stuck, what do I do now? Hopefully that can provide that answer.
Yeah, so there's just the flexibility across culture, language, preference in learning, different approaches. That's really interesting. Thanks so much. This next one is for you, Laila. You touched on generative AI in your presentation. So earlier you shared about how C3 is incorporating large language models into applications like reliability, which you showed. And maybe this is a bit of a given with my earlier comments around how generative AI is transforming the human-machine interface. So the question is generative AI going to become standard for all industrial software applications with natural language interface, and should we be preempting and making investments now if it's a given?
I am not an oracle, so I can't predict the future. I think over time, AI will be part of everything that we do. It already is part of most of the applications and tools that we use day to day. Now, has that made its way into industrial operations, and especially not the large language models yet, but AI generally, I think, is starting to be adopted into industrial operations. And C3 was very early in that phase when we started working with industrial companies 10, 15 years ago. The idea of AI was very foreign. We just had to convince people to migrate their data to the cloud. So I think we're facing kind of a similar phase of transition today, where people are thinking that large language models, generative AI will be useful, but they're not yet sure how or how to get there. So it's hard to say whether or not it will become the de facto standard for industrial operations applications. I think there's still a lot of utility for operations and engineering to look at data. That's where any data scientist starts, is they start by looking at data manually. So I still think there's value in other ways of querying and interacting with industrial data. But I think over time, the large language models and generative AI will be embedded in different ways of working, and maybe it won't look exactly like the troubleshooting guides that we are rolling out today with C3, and maybe it will look really dramatically different, but I do think it will be adopted more and more going forward. And so to answer the second part of your question, should organizations start thinking about what they need to be doing today in order to enable that? Yes, I think it's imperative. Otherwise, you just won't keep up. And so that could look like, if you're not yet working on a cloud, maybe get started with a cloud provider. It could look like, what are the time series historians in place, and can you start to unify those into some predictive maintenance type applications, because making those incremental steps will make it faster and easier to be able to scale AI to other types of use cases.
One word which you mentioned, which really stands out for me, is utility. And as you all know, the various different software applications which are in use across your different technology stacks, it requires experts in those particular applications to be able to interrogate them and get value out of them. So it's really interesting, that whole utility, and how generative AI can really reduce the barriers to entry for getting value out of these different applications, which maybe previously may have required an engineer with a chemical engineering degree and maybe 5, 6, 7 years worth of experience. It's now more readily available for people through a natural language interface. I guess a follow-up question is, what do organizations need to be doing now for this new technology opportunity?
Yeah, I think I touched on that. So making data accessible. Just a side story, I was last year out here in Europe visiting with some customers who were scoping reliability use cases with us. And we went and toured one of their plants, and we were trying to decide, all right, which plant should we get started with for this implementation project, and which assets within the plants. And this was a large beverage producer. And so we were walking around one of their manufacturing sites and looking at, the conveyor systems and the filling systems and the bottle washers. And it was highly censored, and you could see the HMIs on the plant floor where they were monitoring various sensors. And so I asked the plant operator who was working, taking us on our tour, I said, okay, so how would we get access to this data? And he goes, well, what do you mean? It's right here. And I said, well, do you have any sort of historian? Is this data being piped back and stored anywhere? And he was like, well, no, but it's stored here locally. And I was like, okay, well, getting us access to that data is significantly more difficult if every machine has a little computer box where the data are being just stored on that machine. And yeah, the operator who's looking at it can scroll back in time for that machine. But if you're scaling that across the entire plant, let alone around the world, it's just not a sustainable approach. And so implementing things like cloud historians and going to the level of what Shell has done, which is really incredible, of a shared cloud historian across all sites globally so that it's just a single instance that we connect into, that is a really scalable approach. But just starting to think through of, how are you going to connect these various systems? Are they all accessible via API, or, are you having to tunnel in through an on-prem environment. So thinking those things through, I think, are some of the very first steps that people can start taking. And then second, from a business process perspective, I think that's really important. It's not just about the technology. Adi talked a lot about this. Richard talked about this. It's about how do people start using and adopting this technology. We've worked with customers where at a different customer visit, I was at a plant in Arkansas, which is like a rural part of the U.S. And, we're getting together in a conference room and everyone's shaking hands. And I looked in, and there were people from our customer site shaking hands with each other. And it's a big company, but everyone is located. It's just in Arkansas, and there's not that many people in Arkansas, so you'd think they all know each other. And I asked, have you all met? And they said, oh no, well, I sit over here in data science. I'm in the digital team, and the other guy said, oh, well, I'm from the business. I sit in operations, and we don't really work together. And so setting up those organizational processes for the different teams to start working closer together, that is hugely valuable, because if data science is just sitting or digital is sitting separately and they're trying to create these AI applications, but they don't have the connections with the business teams, those plant operations, reliability engineering, all those end user teams, then it just will never go anywhere.
Thank you. Back to Adi. From what you're saying, readiness is absolutely key. So whether that's data readiness, architecture, consumption, or people, but going to data and data availability specifically as a key first step for deploying and scaling. I remember in your earlier remarks, you talked about really underscoring the scaling for these operations-focused AI apps. So you work with a number of customers, many of which you had up on the board, so Cargill, Coke, Shell, and many others. Can you comment on what you've seen, good and bad, from a data availability standpoint, and what are some good policies that organizations have implemented to make it easier and faster to deploy these AI applications at scale?
I can comment on it. Let me caveat. I don't think, I'd be careful, and I'd underscore or just comment on what Lila said first, which is readiness is important, but I think organizations that make readiness of data and access, et cetera, a prerequisite never get started. Right? Because what happens then is some combination of IT, security, information, et cetera, become the longest pole in the tent to even start doing something to prove the value to create the business pull. So where we've seen it successful at Shell, at a bunch of other places, is where IT is a very collaborative partner and understands why we're doing something end to end, and is willing to try, right, along with the business. And that pull creates the momentum. If you instead wait for everything to be perfect before you start, you will keep waiting. We've had many examples at C3 where companies have gone off to say we'll sort of get this going after we put the data lake in place or after we connect X and Y. And 3 years later, they have not moved. 4 years later, they have not moved. Because it creates a lot of energy, and the energy comes from the business and from demand for the solution, as opposed to push from the any other sort of service provider within the organization. I think that's a point I want to underscore, which is the one thing you take away in terms of getting started, it is find something that's interesting to the business, that is worth solving, and just go do it, regardless of all the obstacles you will run into, because that's the stuff that creates the momentum to keep going.
Okay, so find partners who can meet you where you're at and get started is the key conclusion I take from that. Nice. So Richard, you mentioned one of the key learnings over the last 5 years of implementing and scaling predictive maintenance has been the shift and focus on business processes. How have you seen that in shifting from scheduled or reactive work to proactive and condition-based?
So, yeah, difficult one. I mean, there are certain things that we will do as scheduled maintenance activities and planned maintenance activities. Those are givens, those are for various reasons we have to do for compliance or otherwise. Where we've seen the shift, and I think we touched on one of the questions as well from earlier on, was that it allows us to focus our efforts more on areas where there could be problems. It allows us to see equipment that potentially needs to be included in a maintenance activity, which otherwise wouldn't have. The result of that is you only have one outage, you only have one turnaround activity as opposed to 2 or 3. So anything we can do to assist the assets in getting to that point is somewhere where we see those are the other benefits. When we talk about the sort of dollar values of this again, those are the difficult ones because of course you're maintaining a piece of equipment that wasn't scheduled for maintenance, which is now costing more money. But what you are doing is you're avoiding a potential future failure of that. So it's incorporating that in the process. Getting the engineers on board with the fact that you can do this. It's not about just because my SAP work plan says this is what I have to do, that's the only way to do it. Where we get additional insights, we will evaluate those, we'll work those with the business. This is all worked by them internally, and they will then come up with a maintenance plan. So,
You talked about getting the engineers on board. What do you think is the biggest barrier to moving from scheduled to predictive maintenance?
Black box modeling. Yeah, I mean, at the end of the day, this is all dark arts, black science. If you're an engineer, how many engineers are in the room here? Put your hands up. If you can't calculate it and there isn't a formula and you can't see the calculation of how somebody came to that conclusion, you don't trust it. This is part of the change management. It's highlighting those things. It's bringing people along the journey with it. We can go through the whole philosophies of change management, and yes, you've got a whole group of people who will never be brought along. They will continue to refute this. We tried this 5 years ago. We did this 10 years ago. 15 years ago, it was a failure. It never worked. Times have changed. Things have moved on. I think the likes of ChatGPT are kind of helping in the space because even they are going, oh, hang on a second, maybe there is something here. But it is a journey, and it's a constant journey. It's not changing. The great thing is you do get some people who are really strong proponents of this approach because they realize we can't create these models for 10,000 pieces of equipment at a refinery, but we can do it with AI. So they're the ones that you grab along and you say, right, you're a spokesperson, come along, work with your colleagues, bring them along the journey as well. And we suddenly find we start building up the sort of ground movement of this and start, let's say, embedding it more.
You mentioned strong proponents and change management. Many organizations out there have a number of sites or plants, and what we find is many of them have decentralized business processes and technologies without a lot of central corporate oversight. So for Adi, how do you see AI technology adoption and scale out in this situation, and what kinds of standards and business processes are helpful to help these businesses get value at scale in this decentralized corporate structure?
It's an interesting question. I think there's two levels of this. For the same type of process asset that different assets might have, different locations might have to deal with, even though there might be completely individualized processes, the core of what needs to be done stays the same, which is I need to monitor certain in a process equipment monitoring type of world. I need to monitor things. I need to proactively intervene, investigate certain things every day or every week. And at the right time, I need to intervene physically, meaning I need to send out a crew or I need to do something that prevents a catastrophic failure or a big issue. Same story for process equipment and so on. I think if you are able to generalize to those key elements and provide, to Richard's point, the explainability, the data, the underlying why to the people that make those decisions, you can actually drive more commonality and scalability regardless of independent processes. That's kind of level. That's at a level where we're talking about the same thing across different places. Where it gets even more interesting is when you say, okay, now how about I use the same concept I built for one business unit, let's say it's the petrochemical business unit, and then repeat that in the hydrocarbon world or some other world, right? And is there commonality there? We're starting to see that to be true as well. And to Lila's point, when she showed you the app, a lot of the core elements of what you see are the same, but how they may be presented to a user may differ, right? Because certain business units want to see it this way, others want to see it the other way. And that if you can lower the burden of doing that customization to where it is a matter of days and a few weeks as opposed to months and years, then suddenly you can actually do both. Right? It turns out that's kind of where we invest in the technology. I think the key thing, and I'll just sort of echo what Richard and Lila both said, is the key thing is actually the change management, which is the question we always ask in these settings is, imagine the system works perfectly. And it doesn't, but imagine it does, okay? Which means you get perfect, 100% foresight for any alert impacting your process a week in advance, right? Or pick a time, 3 months in advance, 2 months in advance, whatever. The key question is, what are you going to do different? What evidence do you need to convince yourself? And then what are you going to do differently? And if you can answer those two questions, and the answer to that second question is directly tied to business value, then you're in business, right? Because you can just get those two things right.
Thank you. And this tees me up nicely for my next question for Lila. So it's a critical one. I know that, Richard, you've mentioned black box models. We've talked about understanding the why. And Adi, in one of your earlier comments today, you said this is a people sport. So specifically for our people in the audience, what should they be looking for from their AI technology partners to get people to trust the technology? So panel operators, control room engineers, and other decision makers, what exactly should people be looking for?
Yeah, I think it comes down to maybe three things. First, and I'll touch on each of them. First is how do you get to a live application, and what is that kind of adoption and training? Two is how are you presenting the data, and what data do you present? And then third is the quality of the data. So on the first piece, I mentioned this before, but making sure that the end users or the subject matter experts are working very closely with the data scientists and the digital team that is developing and implementing the solution. So as long as the end user is part of that design process, then they will understand how the algorithms are created and validated. And they will go through and on a weekly or multiple times a week basis, sit down with data science and understand, all right, what is the data that's going into this model? What is the output of that model? Is it good? Do I agree? Where would I differ? And then they're kind of in this iterative process. Now, if you can set that up to be an ongoing relationship, not just a one-time exercise, that's best, because then their feedback over time, once there is something that goes wrong, it can be incorporated and fed back into the data science team to improve over time. And so then they know that, number one, they're being listened to, and number two, they kind of see this process play out and they understand when does the model work well and when does it not work so well, and so that they're really embedded in that process. A second thing is just how the data are presented. So that is the widgets on the screen or the charts that you show. What are the different types of, maybe you incorporate some of the physics-based models and metrics, the calculated values as part of what's being displayed on the screen. That's something that we've really prioritized in our reliability application, but you can customize and change and decide how much detail you want to go in and how much flexibility you want users to be able to go really, really deep in investigating what is being presented to them from the AI model. That's actually one place where I'm really excited about the generative AI capability, because I think it makes that whole experience a lot more interactive. It's no longer just a dashboard that is displaying information and allowing users to kind of filter and scroll back in time, replay history, but now they actually get to ask questions and be, part of this conversation about the data itself. And then the third piece is, we've talked many times today about no data are perfect. And so exposing those issues directly in the user interface so that it's not hidden behind some veil of mysterious, where is this data coming from? As part of the reliability application, we surface, when are there sensor health issues? Is there a sensor outage? Is the sensor consistently out of bounds? Has it flatlined? Is there missing data? That's really, really important, because if I have 90% of the sensors feeding this model are bad, then why should I trust this at all? I won't. I'll just reject it. And hopefully, actually, the application will just mute those alerts because they're nonsense anyway. But making sure that users have that visibility into what is the underlying data and what is the quality of that data is kind of the third piece, just in terms of operationalizing.
Thank you. Two more questions. Penultimate one for Richard, and then we'll close with Adi. So Shell has quite a mature digital program, and as you showed, you've been at it for quite a while and have made some quite big investments, and you also have quite a mature AI-based reliability program. So what would your one bit of advice be to asset owners and operators out there who maybe aren't at quite a mature level as yourselves? What would your one bit of advice be?
It's a journey, and the journey starts with the first piece, as Adi mentioned as well. There's no point trying to wait for everything to be in a perfect state, ready to go, because you'll be waiting forever. We made the conscious choice when AI was, let's say, still in its infancy in many areas, to embark upon this, because we knew that if we didn't start now, we would find ourselves 5 years down the line saying, why didn't we start 5 years ago? Because we'd be 5 years behind. So you have to take that first step and start working towards it. We started with the mantra of define small, fix small. Keep it simple, keep it basic, down to the things that are important, the things that add value, the things that you can prove and report out and talk about, and bring people along with the journey. So it's not really one thing, but it is, you have to start somewhere.
Okay, thank you. Nice, practical, pragmatic comments from the engineer. Thank you. So my last question is for Adi. Again, with your experience and exposure to the various different programs that C3 has with customers, what would your one parting advice be to people who haven't quite got on the journey of AI-based applications at scale?
Well, I'll make two comments there. One is, remember, it's a journey and get started. Right? Don't wait for it to be perfect. It will never be perfect. Just get going. And two, make sure that your first 3 to 6 months, you prioritize something that you can use to create energy in the organization. Right? And what I mean by that is pick a problem that you can solve, that you can demonstrate, you can show off, that you can get executive support for and excitement behind, because that first win gets you the sponsorship and the funding to keep going. So pick the right problem up front that shows well, is valuable, and if you do that well, then the rest of it happens automatically.
Thank you. Well, with that, we will draw today's event to a close. Just going back to the opening question about why Gen AI is such a big deal in asset reliability and predictive maintenance, hopefully you've been able to answer that question somewhat, and we'll take our questions into lunch, if that's okay. We're running a little bit over. But as a final plug, C3 AI has a phenomenal executive conference on digital transformation and AI. It's called C3 AI Transform, from March 5th to March 7th in Boca Raton in Florida. Look it up. There is a lot of media on YouTube. It's really, really insightful. Search for C3 AI Transform 2024, and if of interest, register. With that, thank you very much to the speakers, Lila, Richard, Adi, and to all of you for coming, braving the elements, the disruption. Some of you have come from near, some from far. And with that, we'll close the event. Thank you very much, and let's go and enjoy some lunch. Much appreciated.